Assalamualaikum and hi everyone. So for today's lesson, we are going to enter the new topic which is chapter 3 momentum and impulse. So first, let's look at the learning outcome for 3.1a. At the end of the lesson, we are going to define two quantities, momentum and also impulse. Okay, so first, kita tengok dulu the definition of momentum or linear momentum. Okay, so linear momentum is defined as the product of mass of an object and its velocity. So P or momentum, it's actually the relation between mass and its velocity. So as long as an object has mass and also it's moving, so the object will have the momentum. Okay, so momentum is a vector quantity. Obviously, we know that velocity is a vector quantity, so that's why momentum also a vector quantity. Tapi mass bukan vector, it's a scalar quantity. Alright, so the direction of momentum, macam mana kita nak determine dia punya direction? Kita just tengok pada direction of velocity. So direction of velocity, dia akan bagi direction of momentum. Okay, now, since kita tahu momentum adalah relation between mass of an object and the velocity, so mathematically, kita boleh define momentum as P equals to mass times velocity. Okay, so mass, the unit of mass is kg and velocity is ms negative 1. So we have the final unit for momentum in SI unit, which is kg ms negative 1. Okay, so next, let's look at the application of momentum in our daily life. Okay, contoh kalau kita tengok dekat sini, a fast moving car has more momentum than a slow moving car of the same mass. So kalau kita imagine contoh Honda City ada dua, satu dengan speed yang lebih tinggi berbanding dengan lagi satu kereta, lagi satu Honda City, obviously the first Honda City will have more momentum because the velocity is higher compared to the other Honda City. Okay, kita boleh compare car yang sama sebab dia mempunyai mass yang sama. Okay, tetapi velocity yang berbeza. So that's why kita kata momentum of the first Honda City is greater than the second Honda City. Contoh yang kedua, okay, a heavy truck has more momentum than a small car moving with the same speed. Okay, so kalau kita imagine, contoh gambar ni, kita ada truck, okay, and a car moving with the same velocity. Obviously, kita tahu yang truck ni akan ada more momentum compared to the red car. Okay, the speed is the same. The mass of the truck is greater compared to the mass of the car. Okay, so the truck will have greater momentum. Okay, so bila kita cerita pasal momentum, the magnitude of momentum dekat sini, okay, the more momentum than the object has, the harder it is to stop it. Let's say, kalau a truck tadi dengan car tadi, they collide, okay, collide to each other. Okay, so obviously kita tahu yang mana yang lebih susah untuk stop. Okay, yang lebih susah untuk stop, obviously yang ada greater momentum, which is the truck. So that's why kita boleh conclude yang the greater effect it will have on another object if it is brought to rest by striking the object. Okay, so maksudnya car tadi, dia punya mass is lighter compared to the truck, dia akan have more impact compared to the truck. Okay, dan truck tu lagi susah untuk stop because it has greater mass compared to the car. Okay, so contoh yang kita boleh bagi dekat sini adalah, okay, heavy and fast moving truck can do more damage than a slow moving motorcycle. So kita compare dua objek yang obviously lebih berat. Truck tu lebih berat compared to the motorcycle. So bila diorang collide, okay, contoh dia ada collision between the truck and motorcycle, and the truck, dia punya speed is higher and the mass is greater compared to the motorcycle. Obviously, motorcycle tu will have more damage lah bila diorang collide. Lagi-lagi, kalau motorcycle tu speed dia lebih kurang, so dia senang nak hancur lah. Kita akan assume dia senang nak hancur lah bila dia berlanggar. Okay, contoh dekat sini, kita boleh bayangkan lah, a car and a motorcycle crash towards each other. Okay, obviously motorcycle ni akan terpelanting lah. Okay, ataupun dia akan lebih more damage compared to the car. Alright, so next kita tengok, kita tahu momentum ni is a vector. So daripada chapter 1, we already know how to resolve a vector quantity, okay, into x and y component. So contoh ini adalah momentum P and dia punya direction adalah theta from the x-axis. So to resolve P into x and y component, okay, kalau x component obviously kita akan gunakan cos theta sebab theta yang kita gunakan dekat sini adalah from x-axis, and for y component kita akan gunakan sin theta. Okay, so if you use different theta, for example theta is if you are using theta from y, obviously untuk x dia akan jadi sin, untuk y dia akan jadi cos. Okay, so siapa yang tak sure apa yang saya tengah bagi tahu ni, revise balik chapter 1. Okay. Okay, next let's look at the definition of impulse. So the symbol represent impulse is capital G. Actually, we have two definition of impulse. The first one is the relation between impulsive force and the time interval. Okay, so impulse ni kita boleh imagine macam, let's say an object with a force acting on it for a short amount of time, for example. So we can calculate the impulse acting on that object. So as long as there are the force and there are the contact time between the object and the force acting on the object, so there will be an impulse. Okay, kalau kita bayangkan contoh, hitting a ball with a bat. Okay, so yang first ni kita tengok, katakanlah awak main rounders kan. Okay, siapa yang pernah tengok atau pernah main rounders ataupun softball, so kita pukul ball tu dengan bat. So maksudnya kita apply force on the ball, so kita boleh calculate the impulse on the ball. Ataupun kita kick a ball, so sama juga we give a force on the football, and obviously akan ada impulse lah acting on the ball. Okay, dan dia akan ada very short contact time between the ball and the bat. Okay, pemukul tu ataupun force yang supply by another object. Okay, so mathematically we can write the equation for impulse as J equals to F average times with delta T. So from this formula, we can simply conclude that the unit of impulse is Newton second. Ataupun kita boleh keluarkan base unit for Newton second is kg/ms -1. Okay, so itu untuk first definition impulse. Second definition impulse adalah change of momentum of the object. Okay, so bayangkan contoh tadi. Okay, bayangkan contoh tadi. Kalau kita kick the ball, okay, kita kick the ball. Katakanlah the ball tu initially at rest. Okay, initially dia punya speed of the ball is 0. Obviously, bila kita apply a force on the ball, dia akan change its velocity. So, velocity dia akan increase. So, dia ada value for final velocity. So, there will be change in velocity of the ball. Okay, so another formula for impulse, since it can also be defined as change of momentum, so we can write the formula of impulse as change in momentum, which is delta P. Delta is actually the symbol for change. And then we will have different value of momentum final and initial. So we have to minus since we are calculating the change of momentum. And from the definition of momentum, it's mass times velocity. So momentum final is mass times final velocity minus with momentum initial, which is mass times initial velocity. Okay, so this is what we call as impulse momentum theorem. So maksudnya impulse ni dia adalah benda yang sama dengan change in momentum. Tapi kita tak boleh assume yang impulse tu sama dengan momentum initial or momentum final. It has to be change final minus initial. So, kita dah check tadi apa SI unit bagi impulse. That's why kita akan assume impulse dengan momentum dia ada unit yang sama because it's mass times speed kan. Okay. So, impulse dengan momentum ada simbol yang sama. So, boleh tulis sebagai Newton S, okay, Newton second or kgms -1. Okay. So, impulse also a vector quantity. First, kenapa dia vector? Okay, daripada first formula J equals to F times delta T. F is a vector quantity, so J will be a vector quantity. Okay, and then untuk dia punya direction pula, dia akan follow the direction of the impulsive force. Okay, sama juga untuk equation yang kedua, impulse momentum theorem. So, impulse ni akan follow the direction of final velocity. Alright, so kita tengok the first example in this chapter. We are going to solve problem related to impulse and impulse momentum theorem. Okay, so let's read the question together. A 500 gram of squash ball is traveling towards a wall on its right. Okay, dia bagi direction with a speed of 5 meter per second. So obviously ini adalah initial velocity. That is the mass of the ball, and then that is the initial speed of the ball. It then hits the wall and bounce back with the same initial speed in 0.3 second. Okay, so first kita kena imagine macam mana situation soalan ni. The ball is travelling towards the right, so that is the ball with an U equals to 5 ms -1 towards the right and towards the wall. Okay, and then the ball will be bounced back. Okay, sampai sini dia akan bounce with the same speed. Okay, so V equals to 5 meter per second. V equals to 5 ms -1. Okay, with the same speed but to the left. So there will be a contact time which is 0.3 second between the ball and the wall. So dekat sini, satu benda yang kita kena tahu, our direction of V mesti include the sign. So initially the ball is moving to right, so U is equals to +5. And then bila ball to bounce back from the wall, the final velocity should be negative because it's traveling to the left. First question is, find the initial momentum of the squash ball. Okay, so bila they mention initial momentum, so obviously we need to use initial velocity. Okay, so the definition of momentum is speed times equals to mass times velocity. So we will be using the initial speed, which is 5, not the final speed. So the mass of the squash ball is 0.5 kg times with the initial velocity, which is 5. So we will get the answer, which is equals to 2.5 kg ms -1. Or you can write the unit for momentum, which is also Newton second. Alright, so that is the first part of the question. Okay, let's look at the second part of the question. The question asks for find the impulse on the ball. Okay, I already changed the question from off to on here. Okay, so that awak clear lah apa yang awak nak cari. Impulse on the ball. So kita boleh bayangkan macam force acting on the ball. Okay, so untuk yang kedua, for B, kita tahu impulse ada dua formula. J equals to F average times with delta T, or J is equals to change in momentum, which is mv minus mu. So ada dua formula. So which formula that we are going to use? Okay, we are going to use the second formula. Okay, the second formula. Why? Because we have the mass of the ball and also the initial and final speed of the squash ball. Kalau nak guna formula first, kita belum lagi ada average impulsive force dekat situ. Kita hanya ada contact time sahaja. So, untuk kita gunakan formula ni, to calculate the impulse on the ball, obviously kita akan gunakan mass of the ball. Okay, so mass, factoriskan mass, so dia akan jadi V minus U. Mass of the squash ball is 0.5. The final speed is -5. Ingat, that's why pentingnya kita tambah negative sign dalam final velocity kita, sebab kita kena masukkan dalam soalan. So, -5 minus with 5. Okay, so kita akan dapat the answer will be negative. -5.0 kg/ms, -1 or Newton second. Okay, so impulse dengan momentum dia ada unit yang sama. So, why is it negative? Kenapa negative? Okay, first kita tengok the direction of velocity final ni to the left. Macam saya kata, impulse akan follow direction of velocity ataupun force. So, the impulse on the ball comes from the wall. So, macam kita bayangkan wall is pushing the ball to the left. So, kenapa dia negative? Because the direction of impulse is to the left. Alright, so kita tengok the last question, C. Okay, C. Calculate atau find the impulsive force on the ball. Okay, ni dia minta impulsive force. So, kalau impulsive force, kita ada satu lagi definition of impulse, which is impulsive force, average impulsive force times with delta T. So, we already have impulse, which is -5 from question part B. So, we are looking for F average. So, delta T is the contact time, which is 0.3. So, you will get the impulsive force that is equals to -16.67 Newton. Okay, so jangan letak Newton second pula. Ini adalah F kan. So, F average sama juga negative. Kenapa dia negative? Since impulse from the wall to the ball is to the left, so force pun akan to the left juga. Okay, so boleh tahulah kenapa dia negative, because the force is to the left. Okay, direction dia ke kiri. Our next learning outcome is 3.1c. Determine the impulse from FT graph. If we plot a graph of force against time, we can actually find or calculate the magnitude of the impulse. So, kita tahu yang definition of impulse is J equals to F average times delta T. So, maksudnya, kalau kita ada graph of F against T, okay, F against T, we can simply calculate the impulse by calculating the area under the graph. So, as long as y-axis dia F and x-axis dia T, so kita just kira sahaja dia punya area. Okay, kita just kira sahaja dia punya area. Okay, area under the graph. So, kita akan dapat the value of impulse related to situation tu lah. Okay, so try tengok example 2. Okay, example 2. A body with mass 5 kg experience a force which varies with time as shown in the figure. So, that is the graph of force against time. What is the change in momentum of the object after 4 seconds? So, memang dekat dalam graph ni, dia tunjukkan time, variation of time from 0 to 4 seconds. Alright, from 0 to 4 seconds. So, memang kita kena cari the change of momentum for the whole time lah, from 0 to 4 kan, after 4 seconds yang diminta. So, change in momentum is actually the definition of impulse. So, kita tahu impulse is equals to change in momentum. So, we are actually calculating the impulse. And kita tahu juga, if given force against time graph, okay, given force against time graph, kita boleh simply assume that the area under the graph is actually the impulse. Okay, so just kira area under the graph sahaja. So, the area under the graph, kita boleh guna trapezium terus kalau nak. Or kira separate lah. The first one is triangle, the second one is rectangle. So, just total up the area. So, saya akan terus gunakan trapezium. Trapezium is, the formula is half And then we have to measure the parallel length, the length of the parallel sides. So we have the first side, which is 0 to 4, that is 4. And then the second parallel side, there is 2. So plus 2 times with the height, which is 10. Okay. So 4 plus 2 is 6 times 10 divided by 2 is 30. So unit for impulse is Newton second or kgms, -1. That's the end of our first subtopic in chapter 3. So for tutorial tasks, do all question in learning outcome 3.1. I think question 1 to question 5. Okay, so try to buat kelima-lima soalan ni sebab untuk learning outcome 3.1 ni, first subtopic ni dia agak senang. Okay, so I'll see you in the next tutorial and thanks for watching.